Okay, this video will cover page 1 of the supplement review packet. This is dealing with the end of chapter 7, which is material that we covered for the first time this year. I've never taught it before that. So the first page contains conversion problems for vectors from coordinate form or vector form to polar form. So for the first section, it says convert each of the following vectors to polar form. So what they're giving you is they're giving you an x and a y. And they're expecting you to use the equations r squared, we'll write it as just r. R equals the square root of x squared plus y squared to find the magnitude, and theta equals the inverse tangent of y over x to find the direction. These will be found on your reference sheet the day of the final. So what we do is we go in here and we say, okay, x is 4, y is 8. And we literally just plug these in to those equations, x squared plus y squared. So that's the square root of 4 squared plus 8 squared. And whatever that is, it doesn't matter what that is. Okay, we're just going to write that number down. It doesn't matter if it comes out as a reduced root, if it comes out as a whole number. We're just going to keep whatever the calculator tells us for the magnitude. So the square root of 4 squared plus 8 squared is 4 root 5. 4 root 5 for the magnitude. For the direction, we're going to take the inverse tangent of y over x. That's 8 over 4. So the inverse tangent of y over x. Second tangent, feed the calculator. That is 63.43 degrees, and nearest hundredth is more than accurate enough. Then we write our answer in polar form, which would be 4 root 5 at 63.43 degrees. So again, pause the video, try the next one, start the video back up, see if you did it right. So x is negative 5, y is negative 1, r is the square root of x squared plus y squared. When you feed that to the calculator, make sure you're putting parentheses around those numbers so that you don't screw up. That would be the square root of 26. Theta is the inverse tangent of y over x. Feed the calculator. Get 11.31 degrees. So that's root 26 at 11.31 degrees. Again, pause the video, try to get out ahead of me. So x is 1, y is negative 5. So r is the square root of 1 squared plus negative 5 squared, which is the square root of 26 again. Theta is the inverse tangent of y over x, that's 5 over 1, which is going to be a totally different number. Negative 78.69 degrees. Now this raises an interesting point because that is not in the first rotation. So in theory, what we should do is add 360 degrees to that to get the coterminal angle of 281.31 degrees. But I would accept either answer. But technically the correct answer is root 26 at 281.31 degrees. If you wrote root 26 at negative 78.69 degrees, I would probably not have a problem with that. Okay, x equals 7, y equals 13. So r is the square root of 7 squared plus 13 squared, which would be the square root of 218. Theta is the inverse tangent of y over x. That is the inverse tangent of 13 over 7, which is 61.70 degrees. So we'd say root 218 at 61.70 degrees. That does it for the first 4. There are 4 more, so let's get out ahead of me here. While I'm cleaning up this page to put on Google Classroom, you should already be trying the next 4. Okay, so here there's only two more, I guess. All right. So number 5, x is -4, y is -3. So r is the square root of x squared plus y squared. That would be 5. It would be 16 plus 9 to 25. Square root of 25 is 5. Theta is the inverse tangent of y over x. Feed the calculator. That is 36.87 degrees. So we'd say 5 at 36.87 degrees. And finally, x equals -5, y equals 12. That negative didn't turn out the way that I wanted it, so I'm going to clean that up real quick. So r is the square root of x squared plus y squared, which would be, when we feed it to the calculator, 13. And theta, the direction, is the inverse tangent of y over x. That would be -67.38 degrees. Again, we should add 360 to that to get the coterminal angle. That is in the first rotation, 292.62 degrees. And that should be the number we provide in our answer. But if you provide the negative angle instead of the positive coterminal angle, I will allow that. The other half of this page converts the opposite direction. So we're starting with vectors in polar form, and we're converting them to component form. So that is very similar. There are two equations that will be on your reference sheet. X is equal to r cosine theta, and y is equal to r sine theta. So we're doing something very similar. R is 11, theta is 144. So what we're doing is we're saying x is 11 times the cosine of 144, and we're feeding the calculator. That is -8.90 when we round to the nearest hundredth, which is fully acceptable. And sine is 11 times the, y is 11 times the sine of 144, which would be 6.47. So in vector form, we have -8.90, 6.47. So we write it in vector form. Notice the triangular brackets that list this as being a vector. So again, pause the video, try to get out ahead of me. Make sure you've tried the next one before you allow this to continue. R is 18.3, theta is 253 degrees. So x equals 18.3 times the cosine of 253 degrees, and y is 18.3 times the sine of 253 degrees. Feed the calculator. That is -5.35 and -17.50. So in vector form, we would write that as x comma y, -5.35, -17.50. On number 9, r is 4. Theta is 241. So x is 4 times the cosine of 241 degrees, which would be -1.94. And y is 4 times the sine of 241 degrees, which is -3.50. So if we round off properly in component form, we would be looking at -1.94, -3.50. And finally, r is 22.6, theta is 44 degrees. Notice that's first quadrant, so both numbers should come out positive. So x is 22.6 times the cosine of 44 degrees. Feed the calculator. That is 16.26, and y is 22.6 times the sine of 44 degrees, or 15.70. So 16.26, 15.70. That does it for page 1 of the supplement.